Hei, Laptopix, Murros, bună ziua, salut. Good afternoon, phone repairs. Morning, guys. Morning or, yeah, still morning. Still morning. The video is public, right? Privacy members? How? Wait 1 second. What happened here? I don't understand. It's subscribers, right? Why are you saying members only? I mean, check here. Check here. Subscribers, right? It's not members. So why the live stream is members only? Why is that? I think I found the problem. Tell me if it's public, huh? It is? It's public? Happy Sunday! Yeah, it's a beautiful day outside. Sunny, like 11 degrees. You select, yeah, I select public subscribers. You seen the setting. You seen that. And now it's public. Should be public. I mean, I can see like 46 people there, but only the subscribers can write on the chat. I did a refresh it, now it's public, but look on the chat. No one else is writing. Oh yeah, it is. Okay, or not? Yeah, it is. Good morning, guys. Let's speak. I seen a video today. Yeah, proper interesting one. Boardrev, hello. Silvio, hi. Sorry, was a setting issue. I mean, even now I don't understand. It was meant to be public. Good morning, guys. It's still morning, like 11:30, but still morning. Hello. So everyone can see the chat. Everyone can write on the chat. Yeah. No coffee. Ha. What about something like that, huh? It's like I'm away from like 1:30 in the morning. It's like, for me, it's nearly the day is gone. And not really coffee time right now. Happy birthday. Thank you. It was a while ago. Always better than a glass bottle? Exactly. I tried to explain to Diana, it has a different taste compared with, the plastic bottle or even the can. It has a different taste. But Diana said, no, it's the same. Well, it's not. It's not. Too late today? No, actually we are too early. What do you mean too late? Now, this is not a coffee stream, yeah? Let's do analyze today, yeah? We publish the video in the morning. Hopefully you've seen the video from the morning because it will make more sense. Hi from Germany, hello. Try mountain twin? I don't like it. So guys, what about the Inrush current? Huh? Everyone knows what it is and specific faults? Hello. Capacitor. No capacitor, no short capacitor, right? Let's wait a little bit for the people to gather here. Manny, hi from Philadelphia. Good afternoon, maybe. In sympathy, hi Sorin. Hello. How is everyone, huh? Everyone had a good week? Busy? Those capacitor. This is my capacitor. This is like on my when I was like a young guy, this was gold, for audio amplifiers. You want like big capacity. You see like this one, 63 volts, 4700. Do you pass 500,000 subscribers? Who cares? Let's be honest. I don't. Inrush current, like if a capacitor doesn't do his job for attenuating, the capacitor is creating. Yeah, is creating the inrush current. Have you ever thought about this? For repair or inrush current, Borev did a video. Now I'm not looking to begin this video. Sorry. I'm just joking. I'm speaking about his video. I mean, I seen the video. He texts me. I'm a subscriber, but I didn't see the video. I seen the video in the morning. I said, you know what? I have to do a video about this. Then I start the video. I can show you the video. I start the video, and I stopped the video. I said, you know what? Let's do a live stream. Yeah, because that was quite a pro approach to a fall like that. Yeah. It's about his video. That's the reason why we start this live stream. It's about my video from the morning and his video. When when I see a good video, I have to speak about it because I was surprised. I mean, okay, the gate is capacity, but I never thought actually, even that capacity matter. And you replace the MOSFET with a different MOSFET, then you have a different capacity there. It was a good video. Okay, let's see about the inrush current. We have a capacitor here. We have some voltage. Yeah. Now check here, yeah? No, minus. Oh, lol. Minus, plus. Like a big spark. I got scared. You seen that? You seen that? Yeah, that's inrush current. Okay, clear what is the inrush current. So the motherboard, a laptop motherboard, is full of capacitors. Yeah, all connected to the main power rail. When the current is coming, you plug the charger, right? The capacitor, a discharge capacitor like this one, it's exactly like a short circuit. Yeah, nothing else. It's a short circuit, 0 ohms. So that's the inrush current. You see, even if I like a short this or I charge the capacitor, it's the same thing. It's a short circuit. So the inrush current is up to 100 times higher compared with the normal working current. So even on the laptops, plug the charger, that laptop is taking 10 amps. Inrush current is 100 amps. You have 100 amps on the charger? No, you don't. The charger, it will protect itself, it will cut the power, and end of story. We use Inrush current limit along on big power audio amps. I don't remember that. I swear I don't remember. Why you will use something like that on an audio amplifier? I can't see the point. Huh? For repair. Because you need high current there. You know, when you have a base, that base is taking a lot of current. Hmm? Hi, Sorin. It was the BQ chip from the Acer Predator you posted. Exactly the same, the new one that worked. No, it doesn't even matter. What do you mean? They're all the same. Like, you know, I think it was original was 2781, I think, and I used 2780, but it's less important. Hello. Sorry for my bad English and French. Okay, so everyone's seen the video from the morning, just to be on the same page. We are speaking today about my video, which was heavily edited. Yeah, I edited out like over 1 hour. And we are speaking, one second. We are speaking about this guy, yeah? We're speaking about pro people. There are few pro people on the YouTube, and he is one of them. Okay, be sure, you know, I'm gonna share the. You have to see this video. Okay, it's important to see this video. We are speaking about Acer Predator, same, or Acer Nitro, whatever. Actually, we're speaking about more things. I seen something very interesting here, which I wanted. So if I will be to change my linear power supply with a switching one, I want that graph. And I will show you after that why. We are speaking about this capacitor. Okay, this one. This one is exactly, where is it? We are speaking about, where is the schematic? I lost the schematic. Where is the schematic? Oh, this data sheet is so big. Yeah. This capacitor, yeah? Q1. 1 nanofarad. You can see it? Yeah, this one. Now, you can use capacitors to add delays. Very simple. If you are speaking about... the problem could be the BK chip was already replaced with the wrong one. Yeah, but why didn't work with my one from the box, which was the same, 24780? Let me pause to slow the charge the cabs. Then with a relay, it's connecting to slow the charge. Maybe I'm missing something because I didn't do audio from ears from when I was like a young guy. Maybe I'm missing something for repair regarding the audio amplifier. And Inrush, maybe, you know what? I don't think, listen, I don't think it's any point having an Inrush current limit on an audio amplifier with a transformer, because transformer itself is a limiter for Inrush current. If you have a switching power supply, that does making sense, because current is going high, it will cut the current, it will go that high, which is not supported by the switching power supply. The transformer, well, you know, the voltage is going down, then it will charge the capacitor, and the voltage is going back, high back, and yeah, everything is fine. Not with switching, definitely not with switching. I agree with you. That's why that's what I just said. Inrush current can be up to 100 times more than usual working current. Exactly. So, we are speaking about the video from the morning, and this video. I didn't share the video, right? I didn't share it. You know, I love when I see like a proper approach using the oscilloscope, you know, like a professional repair guy. I mean, I can't be like that. Don't get me wrong, yeah? I can't be like that. But it was interesting. So on his video, okay, let me read, because he write on a proper way. Not sure if this is AI or whatever. He write it properly. So using the oscilloscope, I captured the exact moment the BQ chip shorts the abort. Abort is a very good word used here. The power sequence. It turns out there was no short circuit. The brand new replacement MOSFETs had a lower internal gate capacity than the factory originals. Yeah, and you have to give. I never think to that, but yeah, capacitor. The gate is capacitive, so obviously every MOSFET has a different capacity. However, after replacing the BQ chip and the first two MOSFETs, the exactly same fault remain. Using the one second. No, I think I jumped somewhere. Okay, yeah, I jumped from one to the other. They were turning on too fast. Yeah, so you have a better MOSFET. Yeah, it's faster than, you know, it's better, right? It's faster. It's a bad thing. Yeah, they were turning on too fast, causing a massive inrush current spike that tricked the BQ into thinking there was a short circuit, right? Throwing it into a continuous protection hiccup loop. Well, in my video, I didn't have that loop. Yeah, it was like trying to do something few seconds, then yeah, that's all. Okay, so we're on the same page, right? We understand this. Oh, really? Oh, Silvio. Oh, that's good news. So actually, I should check on the menu. Okay, I will do after that. Cool. Everything is clear here. So basically, let's go to the BQ chip. Let's check something. The Inrush current protection. Where is that? Okay, it doesn't matter where is. Okay, let's analyze the data sheet. Yeah. So here you have the current sensor of the BQ chip. Current sensor. You have the motherboard. You have a bunch of capacitor. The motherboard is the capacitor itself. It's exactly what I show you with the capacitor. When you come with the power, it's like a short. Yeah. So what they are doing in order to solve this problem, here you have a current sensor. The MOSFETs are slowed down by the capacitors. Okay, you have like this capacitor to slow down the MOSFET, and he show on the video, because that's what is beautiful on his video. He shows on the video. Where is the video? This one. 1 second. Check here. Yeah, check here. With the oscilloscope, you can see it's slowly going up. The current is going slow. Actually, the voltage, because we are speaking about the voltage gate, slowly is going up. So this graph is with original capacitor. Here, he added one more capacitor in the parallel to slow that MOSFET down even more. And on that moment, he limit the inrush current. Yeah. Cool? Everything is clear? That's why you are using the capacitor. You are using the capacitor to slow down a MOSFET. So my case, if you see my video, my case, it was the same. It was like an inrush current. If you slow the first MOSFET, then the current is going up easily. If you do, also they are using inductors. You see inductors. Every laptop has inductors at the input for the same reason. Yeah. if you have like any, let's say you have like high inrush current, then bad things it will happen because you have a current sensor here, it will sense the current. If the current is too high, the BQ chip it will assume it's a short circuit, and it will cut the power down on the first MOSFET. Okay. Cool. It's a cool chip. You know, the BQ chip, it is a cool chip. Everything is clear, right? Just want to be sure everything is clear. How much? You have to cut out more than 1 hour. More than 1 hour I cut out from that video. Everything is clear, right? Need the first transistor to be a special thermistor? No. No. The thermistor powers the AC detect. You don't have a thermistor on the AC detect. Not sure what do you mean. AC detect have nothing to do with the current. AC detect, it's about detecting the charge, the voltage. Yeah, the voltage. AC detect, you can see on this schema, I use like 7 kilo ohms with like 60 kilo ohms. On this one, you have you have 133 kilo ohms with 866 kilo ohms. My bigger resistor was like 60 kilo ohms. Current doesn't matter. No, it's just a divider. It's just providing voltage to AC detect. That's all. That's all. Yeah, that's all. Good. Now let's go back to my video. 1 second. Now I have to search on my video. Okay, this will be long. We're speaking about. Wait, this is 30. Wait a second. I'm checking on the wrong video. 1 second. Because obviously I have to check on the video which I didn't edit, the original footage. The original footage is here. Yeah, definitely we are back. Good. Now let me try to find out. Yeah, just give me 1 second, please. Just want to show you why I knew, and this is not on the original video, why I knew I don't have this problem. And how you can know. 1 second. Let me try to find out. It's a long video, so I have to search exactly for that moment. Just want to compare the results. Wait, that's insane. Yours was simply IAC detect missing signal. Inrush current was not an issue there. It was. It was. Yeah. That's why I'm trying to find the moment I checked with the thermal camera. Why is your hand all scratched up? I'm doing like gardening works. When you're doing gardening works, especially on the spring, when you start cutting all the things, the branches, yeah, you can get hurt. That's what I'm looking for, Silvio. For the moment I use the thermal camera, because at some point I said, you know what, the power supply is slow, and you cannot see the current spikes. And I said, let me use the thermal camera. Yeah, and I use the thermal camera, and I seen something, and that's what I want to show you. What I seen. That's it's edited out from the original video. But I'm trying to find it. And I don't know where it is. And my VLC, it's I don't know why it's freezing and okay. Maybe a video it will be a better idea compared with a live stream. That was a smart thing, yeah? Checking with the thermal camera. Because on that moment I understand what is the problem. Where is the thermal camera? Don't tell me actually it's not recorded. Because I did pause the video a few times. Yeah, it's not. It's not on the video. That's crazy. I can't believe it's not on the video. It's not on the video. Ha. Okay. Yeah, search for nothing. How I could do that kind of mistake? Yeah, it's not on the video. Initially, it was the thermal cam that showed me the first MOSFET pulsing. When I check with my thermal camera, it was the high side MOSFET from the charging circuit. That's how I knew I don't have like your problem. That's the moment how I knew. But of course, I didn't assume I have no problem with the Inrush current protection. So I did check on my way. Yeah, and I'm gonna show you how. That's why I don't like edited videos so much. I know, Sylvie, but if I check you the stats of the channel, you see the people are looking like 6 minutes of a video. Doesn't matter if the video is 1 hour or half an hour, they're looking exactly 6 minutes. I'm trying to make the content friendly for everyone. Um, Unusual late? Nah, we are earlier. What do you mean? Okay, let me show you. I'm happy you are here. I'm happy you are here because you were on your video, and I swear, you are very professional. I really enjoy the video, and I will leave the link on the description with the video. I really enjoy the video.
I think here it was going straight like this, and mine with the cap was slowly creeping out here. You see, it was going like this, and this one probably it was going like straight up. Good, interesting, right? So let's go back and let's fix it back.
Definitely have a look at this video. Very interesting. The way how I approach this kind of fault, I always look for something like that. Yeah, I'm not using it's. I have to go there, take the oscilloscope, then check, and the oscilloscope it will show me something, but I have my way to do it. So my way to do it. Yeah, I'm happy you're here. You have a inrush current problem, and you have a sensor. And my way to go for this kind of fault is to take your finger and put a finger inside of the BQI. Yeah. So if you just to know if you have this problem, yeah, let's say you have like same case, you plug the power, you see a few spikes of current, but it's not starting like a short circuit. My way to do it is by shorting the current sensors. Yeah. So let me find that part because I'm pretty sure I have that part here. Yeah, I'm pretty sure I have that part here. 1 second. And I will show you. I try it. And it was absolutely no change when I short the current sensor. So that's how you go around to inrush current protection. Yeah. You will not limit the inrush current, yeah, but it will you will blind the BQ chip. So the BQ chip it will not see a high current. Did you thought about that? Huh? Give a link to the guy. I put it on the chat. I will put it one more. 1 second. Let me find that. Yeah, definitely I have that somewhere in the video. You know, like someone said, I should do like two versions. Yeah, like short version for the public video and like a long version for members, right? No, I can't believe. Where is it? Give me 1 second. It's crazy. I cannot search on a 2 hours video. It's too much. Haha, I found it. I found it. 1 second. I found it. Finally, I found something. Wait 1 second. I mean, even the BK can be faulty. Yeah. So pin number 5, AC OK. Then plug the charger. Pin number 5 is this one. And it's 3.3. Oh, yeah, no, it's not this one. 1 second. That's the AC OK. Yeah, found it. Yeah. Check here. 12.8. Okay. What I'm gonna do, I'm gonna short. Check here. This current sensor. So that's the battery current sensor. Plug in the charger. I see like 150 milliamps there. But no, still not charging. No. Okay, I'm plugging the charger. And the next one, pin number 1 and 2. Pin number 1 and pin number 2. Exactly. Plug in the charger. This is the input current sensor. Exactly. No, not the current sensors. Yeah, so that's how you fool the BQ chip if you have an Inrush current problem. That's what I did. I'm happy I found. How can I make the writing bigger? Is oscilloscope worth of? Yeah, it is. Yeah, why not? You seen the other video. So plugging the BQ chip, that ultra high current, it will go straight to the board. Of course, it will kill something. Huh? How you can kill something? Kill this one. Yeah, kill. This is the inrush current. Yeah, kill it. Oh, inrush current minus plus. It's a spark. It's a spark. How you can kill it? How you can kill a capacitor by shorting it? How you can do it? How you can do it? You understand? You can't kill it. You can't kill it. Okay? We are speaking about this inrush current is created by the capacitors because you have too much capacity there. And capacity, an empty capacitor has exactly 0 ohms. It's a short circuit. Clear? Yeah. So in order to fool the BQ chip, just keep in mind, you can short the current sensor and the BQ chip will not see the current. Yeah. On this case, you have ACN and ACP, pin number 1 and pin number 2. Then you have SRP and SRP and SRN, the other current sensor, which you can short the pins in order to hide the current over the current sensor. So you can figure it out if you have an inrush current problem or not. That's the point I'm trying to reach here. Are two different methods to, check this. Like you can check with the oscilloscope exactly how you did, and you can see the delay. You can see the delay before and after he added a capacitor. Because that's what I'm trying to say. He added an extra capacity. And let me see if I can find where. Yeah, here he soldered another capacitor on the parallel mode, right? Yeah, it's already soldered there.
With the wind on the board, or maybe that original cap is gone with the wind.
Yeah, he soldered another capacitor there because it's a different MOSFET and has less capacity, and you have not that much delay if you have a better capacity, which switches faster or has less capacity on the gate, because the MOSFET has a capacitive gate. So in that case, it's not like the original capacitor was bad. No, but he need more capacity. The video it's about he has a good fake short. It's a fake short. You don't have a short, but it's a fake short. Clear? You understand? So because he replaced the MOSFET didn't have enough capacity. Then he figured it out with the oscilloscope. Wait, I don't have that much delay there. Yeah, because the capacitor is there to add some delay. So he added more delay by putting another capacitor on the parallel mode with the original one. Pretty smart. Now, my way to go, like I said, my way to check if I have that problem is by shorting the current sensor on the BQ chip. That's my way. So if I short the sensor and, the board has no problem, then I have the main power rail, then I know I have an inrush current issue. No capacitor, no problem. Look, I can check, but it will take long. I said on the video, let me feed this capacitor because this capacitor is here to add some delay. And maybe that's the problem. But that was before I checked with the thermal camera, and I see the MOSFET, the high side MOSFET on the charging circuit actually pulsing short. And then I knew this is not possible. Yeah, this is not possible. Because the charging is delayed. You have a pre-charge current. You have a soft start. If you check the BQ chip data sheet, you have a soft start on the charging. So just seeing that MOSFET, the high side MOSFET, getting hot, like pulsing, I knew must be something wrong with the BQ chip. I knew that. Yeah. So both faults, they were interested. I mean, my one, it was my mistake because I assumed the MOSFET I have is good. I didn't expect the BQ chip to have exactly the same issue with the one from the board. I didn't expect that. Because usually the BQ chip, they are dying on the gate voltage. They are not providing 25 volts anymore. That's how usually the BQ chip are dying. But both BQ chips, they were good providing 25 volts on the gate, but they are not good on charging the battery. Yeah. Typical, the gate source capacity on any MOSFET is picofarads, so only the external caps matter anyway. Silvio, if that it will be true, then means any MOSFET can be replaced with anyone, and that means his problem cannot be real because he added another capacitor and then everything was fine. So he added a little bit more delay and everything was fine. Hmm? So probably matter, or the system was on the edge. Okay, a little bit less capacity and it's not working anymore. I think, one second, a capacitor momentarily pushes and receives huge current. You did some research. Yeah, but we are not researching Wiljad. We are not researching capacity. That's the capacity. That's how the capacitor, you can't do anything. This is a thing, you can't do anything. You put a capacitor, you have inrush current. There's nothing what you can do about it. You can only just limit the charge current of the capacitor. That's all. Hmm? The switch speed is making the difference. Those are not switching MOSFETs, Silvio. No. It's not like a switching power supply. Good morning, good morning. John, happy to see you here. I can't believe John is here. You can believe I told you the John stories, yeah? I told you his story. John, I'm happy to see you here. Hopefully you are better. Hopefully we get home because Thursday we have Last Epoch, new season. Hopefully we can play together. Okay? Yeah, one more time. Check his video because it was an interesting video. This is not advertised. Yeah, don't get me wrong. But I never think, the internal capacity of a MOSFET matter. And the other thing, it was actually he could see the short spikes, and I didn't see on my one. I didn't see short spikes of current on my one. I seen them with the thermal camera. But not on the power supply. They were so fast. I didn't see them on the power supply. With the thermal camera, I seen like a short pulse on the high side MOSFETs from the charging circuit. Okay. Wait 1 second. What I did? 1 second. I'm gonna paste one more time the video. Have a look at the video. Very interesting video. It's just a coincidence. The guy still is Romanian, but the video is on English. So yeah, you can watch it. Just give him a like, subscribe, because really that video deserves something like that. Like I said, I knew about the problem, but I never think, wait, that can happen if you replace a MOSFET with a different MOSFET. I didn't think that. Did you figure out what that unique cap that's missing under the MOSFET went to? Went to? I don't know. It was missing from before, from the beginning. How they are not switching back and forth like that, but they are switching briefly when the BQ. You have wait, Silvio. Wait, I'm not sure what you are speaking. There is like DC current, DC voltage. I know you have like they are. He's checking. It has a how it's called. I forgot how it's called. He's checking like 7 times if the MOSFET is shorted. He's checking from time to time, not 7 times. If 7 times he cannot detect the MOSFET, he will cut down the power. But we're speaking about mainly DC. It will be important. I think it will be important to match the MOSFET. No. Timing matters. Yeah, timing matters. I agree with you. Yeah, timing matter. That's why that delay matter. No, 1 second. Let's get a MOSFET. No, frequency. What do you mean? They are switching like up to 1 megahertz, which is low for a MOSFET. MOSFET. Tell me a MOSFET, like any MOSFET. Okay, I found a MOSFET. 1 second. You have wait, it's not saying on the data sheet. It's saying okay, okay, I got it. You are speaking about this delay, turn on, rise time, and this kind of stuff. Because I was speaking about switching frequency, which I can't see it here. Like, no, nothing. No, okay, probably doesn't matter anyway. Yeah, it's about this, the delays. Okay, I got it. Yeah, okay. And you have check here the capacity. You said picofarads. You have like 1 nano. What do you mean? You have 1 nanofarad. It's not that low. It's not that low. No. It's not that low. You see? It's not pico. It's like 1 nano. No. So capacity matter. Exactly. Will a cap not delay the switching? Exactly, yeah. The cap, it will add some delay. You have a resistor, because you have a big resistor. You have like 4 kilo ohm resistor from the BQ chip on the gate. And after the resistor, you have a capacitor. It's nothing better for a delay circuit than a resistor and a capacitor. I have the same problem with my Acer laptop not charging. The laptop does not take any current, but every voltage is there. Tired of replacing the BQ chip and MOSFETs? Gilby, have you tried to charge the battery with the power supply? Because if the battery is dead, it will not gonna charge. That doesn't mean the laptop has a problem. So tell me. That's all what you have to tell me. You can charge the battery with the power supply or not? Very simple question. Very simple question. Can you do it? Let's solve that problem. Guys, we are still live, or my live stream died? No? No, still live. We have 1 hour. Yes, the battery is charging. You can charge the battery, right? You can charge the battery. We're okay. So the battery is charging. That means the battery is good. When you start the laptop, yeah, Gilby, very, just listen. When you start the laptop, the battery is present on the Windows. You can see the battery level on the Windows. That's all what I'm asking. Simple question. Is the battery present there or not? Because in this way, we can figure it out if the battery is speaking with the EC chip. Just tell me that. What is the best budget-friendly BIOS programmer for a beginner? The CH431 or 341, something like that. £7, something like that. Yeah, 341. Yeah, that's the one. Very good. I was surprised how compatible is. Very slow. Yeah, so it's nothing fast, but like compatibility wise, very compatible. Incredibly slow. Exact. I know. That's the reason why I stopped using it. Battery is detected 100% charged. But if I unplug, switched off. Wait, we are speaking about different things. You said it's not charging. Now you are telling me you unplug the charger and it's switching off. Wait 1 second. We're speaking about different things. I swear we are speaking about different things. What laptop it is, Gilby? Acer laptop. I have a case, yeah? Let me tell you something. I have a case. Let me find that I deleted. 1 second. I deleted, but probably it's on my bin. Should be on my bin. 1 second. Restore. I restored the picture. No, it's not this one. 1 second. It's not this one. But where is it then? Restore. This one. I found it. 1 second. I found it. 1 second. 1 second. Give me 1 second. Yeah, this one. Yeah. So check it out. I had a case. I had a case yesterday or 2 days ago. Check here, yeah? Battery unlocked. You can see that? Check that. It's unlocked. It's saying unlocked. Let me make this bigger. 49 cycle count. You can see that? 49 cycle count. 49 cycle count. Battery unlocked. Balance. Charge state fully charged. Yeah? Health fully health. This battery was not working. Yeah? It was, you cannot charge it because it's full. So you can't test it by charging it. You can't. But it was faulty. It was not providing any power. Yeah, I had this 49 cycles. You can see that. But because it's made by BYD, and is not detected by the NLBA, I could not do anything. I mean, I'm pretty sure this was a firmware error. Yeah, it was a firmware error. From the simple reason, I can see the cells has like 4.2 volts, fully charged, but was not providing any power. So yeah, I had that case. That's why I'm asking. That's why I'm surprised you are saying the laptop is not staying on when you unplug the charger. Just to make, listen, yeah, Gilby, a simple test. I'm going to show you a simple test to figure it out if your battery is faulty or you have an issue with the BQ chip. Yeah, this is a simple test. Yeah, check here. We are going back to the BQ chip. This is a simple test because you are saying the battery is fully charged and it is good. Okay. But when you unplug the charger, the laptop is switching off. It's a simple test. All you have to do is to short this MOSFET, this one. This is the comeback MOSFET. Basically, this is the main power rail, and this is the battery. All you have to do is to short the drain and the source of this MOSFET. Because let's say you have a issue with the BQ chip and it's not, triggering this MOSFET. If you short source with gate, you short source with gate of this MOSFET, not the one which they are switching and they are charging the battery, not these ones. This one. Short this one, and if you unplug the charger and the laptop is not staying on, then it's the battery. Okay? If you short this thingy and the laptop is staying on, then yeah, you have a problem with this MOSFET or the BQ chip. Very simple. What you are telling me, it's a very simple diagnose. Renesas chip is not always recognized by an LBA. Laptop fix. Yeah, depends. You have there. You can pick up manually the one with 40 something, and sometimes it is working. Yeah, but mostly they are not. Yeah, everything is simple if you know what to look for. Come on, it's just a short circuit. Huh? Can you change the stream settings so we can skip back? Don't worry, you can see it after that. Just stay with us now, and you can see it again after that. Check out the video you posted. Sorry, cannot listen to that voice anymore. What do you mean? Okay, I got it. You know what? These kind of videos are not vlogs. Yeah, they are not vlogs. They are not gaming. They are not 10 minutes videos. They are videos from where you learn. And you have to appreciate the guy, which is Romania. He made the video in English, so everyone can understand. I mean, my advice is don't look at the video if you don't have time for something like that. But if you are looking to learn, 1 hour video, 2 hours video, that's no issue if you are looking to learn. But you have to appreciate when someone is doing a video on a language which is not the mother language. I'm just saying. Actually, I really like his English is clear. It's easy to understand. On the learning process, you have a lot to sacrifice, and time is free. It doesn't cost money, basically. So you need some time to watch a video. You don't have to pay for some tools or some components. I'm really sorry, but that's the only reason why I started the live stream. I was properly impressed by that video. When I seen the video, I said, you know what? It is related with my video from the morning, but not quite. Is oscilloscope a must-have tool? No, it's not a must-have tool. I took the battery to another same laptop. It charged fine. And I plug it to the faulty laptop, switch on, and stays on, but not charging. Wait 1 second, GLB, 1 second. Alvaro, thank you very much for your donation. GLB, 1 second. I took the battery to another laptop, it charges fine. I got it. And I plug it to the faulty laptop, switch on, and stays on, but not charging. Light flashing. But if the battery is charged and you unplug the charger, the laptop is staying on? Because you said it's not staying on. You said the battery is charged 100% and the laptop is still switching off. That's what you said. PIH Music, thank you very much. Thank you. You got me into the soldering and burned fingers? Ha! I'm still doing it. You think, like even a few days ago, I stabbed with the solder iron exactly on the finger. I'm still doing it. Yeah, so you're not the only one. You're not alone. Is there any way I could test and unlock the batteries? without using the NLVA? No. It is. There are more ways to test the batteries, but not to unlock them. To unlock them, there is another way. It's another tool to unlock batteries, but it's more expensive. It's like £1,000 per year. I forgot the name of the tool, but probably if you check Google, you can find it. I think they allow you to pay per unlock. So you can pay for 1 year or you can pay for unlock. I believe it's like $10 for unlock. Motoraptor. Mulțumesc mult. Mulțumesc. Thank you, guys. I learned a lot from your video. Hi from Chicago. John is from Chicago. Yeah, John is from Chicago. I said once I will visit Chicago. Sometimes when I will take a break to start visiting countries, I will come there. What is the best source for BIOS firmware, board views, and schematics? Our Discord, Kennedy. Our Discord, because it's free. Yeah, our Discord, because it's free. B2 works. That's how it's called. Chicago is a very nice city. One day I'll be there. Sorry, retiring? Nah, how you can retire if you have no pension? How you can retire? I can't, man. I can't do it. I have to work. I can't. I can stay away from electronics, let's say a few days, but after that I have to do something with electronics. And if I have nothing to repair, I start opening my tools and do like maintenance, like preventive maintenance. No, I can't stay away from electronics. I'm really sorry. No. Make a fortune soldering 4090s in China. Bro, I see some guy on China, like that's freaking impressed me. I mean, the guy was so smart. He was doing only GPUs, but he was like on a different level. I forgot the YouTube channel. The guy was on a different. I never seen something like that. I mean, I'm not speaking about soldering skill. I'm speaking about diagnosing skill. Billy, thank you very much. Live again? Yeah. Why not? I seen a video in the morning and I said, you know what? I have to do a video, but it's freaking Sunday. I don't want to do videos, then edit the videos, then upload the videos. I said I will start a live stream, so I start a live stream. Yeah. How are you doing with the Diablo 4 Season 12? Gabor? What do you mean, man? I'm on top of it. Diana made Pita 109 with her Paladin. I play Paladin. I try every build of Paladin. And I start now with a Druid. And now I have my glyphs like level 60. And I stop playing it because I have jobs. But I play like crazy. I play like, crazy. Electronic is Sorin. Sorin is electronics. Yeah. Home Alone. Didi. Nah, I think it's on the kitchen. I know you recommend heating up the boards from the bottom, desoldering SMD items. Not really. I mean, you didn't see me like many times doing something like that. But sometimes you have plastic parts next to whatever. I have a charging port and here I have a plastic connector. You can't use a hot air. Mulțumesc mult, Motoraptor. Thank you. You cannot use hot air. On that case, you can use hot air from the back of the board, but it's not like I'm usually doing something like that. You have a chipset here from the back of the board. In all laptops, 5 volts is always on before pressing the power button. No, not all the laptops. You have on some laptops you have LDO 3.3 and 5 volts. I've seen some laptops only with LDO 3.3. I've seen some laptops with LDO 3.3, 5 volts, and the big 5 volts power supply. So depends of the laptop. Where can be used that capacitor holding? Anywhere. This can bring only improvement to wherever you put it. How you identify difference between N and P channel MOSFETs? Usually all are N channel MOSFETs. Not all. Most of them, they are N channel. You can have P channels where you have MOSFETs on the serial mode, on the serial mode with your main power rail, or on the serial mode, carrying the current further, but not on the switching power supply. So if you want like a channel N MOSFET, you take that MOSFET from a switching power supply. Otherwise, you can differentiate the MOSFET based on the last number, but it's not always right. It's not always like that. Or by checking the internal diodes, but you can't do it. I made a video, remember? And I said, no, you can't know which one it is. You can't do it with the multimeter. My multimeter, I hate the fact I cannot use the diode mode, because apart from beeping, I'm using diode mode a lot. But this one, it will not show you the diode, plus and minus, because both, it's just showing you have a diode there, but it's not showing you the sense. So I cannot use it. But yeah, you can check by the internal diode of the MOSFET. Very simple with the multimeter. You can figure it out if you channel P and channel N. Unity multimeter diodes mode is crap. Exactly, Sylvie. So if I will change this multimeter, I want a multimeter, and I had before, with the diode mode and beeping on the same time. Can you believe that? Diode mode, it's also beeping. That's what I want. Yeah, it is a crap measurements. I have a doubt down there. Other people want, what is the difference between LDO 3.3 and 3.3 always on? Are there different buck converters? The LDO is not a buck converter, it's a linear regulator. Yeah, that's why you short the LDO and you see the chip providing the LDO getting hot. That's the only reason. It's a linear power supply. What about using gate voltage? You can. A little bit more complicated because there can be different configuration. Like the Acer we are speaking, where on the gate you have like 25 volts. But if you check the gate with the source, actually you have like 6 volts. Aren't the N channel MOSFETs mostly connected to ground? And the P channel on the whole? No. No. That was like years ago, like 20 years ago. You have a channel channel P, one channel P and one channel N on a switching power supply. It's not anymore. The both MOSFET are channel N. But you had the source connected together. So you have the drain on the high side to plus and the drain on the low side to minus. If the energy crisis will start, will you buy solar panels? It's England. We don't have that much sun here. Energy crisis. There's no energy crisis there. I seen yesterday a video about how the electricity price is make up here. So everyone from the country is paying the electricity as a gas generated electricity. That's how it's set up by the government. And the gate was AC. It was not AC, it was PWM. Why I can't find Type-C cables for my power supply? Type-C cable for the power supply. I don't know what power supply do you have. You mean like my setup? My setup, check I have an Amazon link, and there you can find my adapter I'm using. Okay, guys, I think we made it clear. Two different approach from that video with the oscilloscope, yeah, and the Doji approach, like Sorin approach. You short the current sensors, and you blind the bigger chip in knowing actually you have a inrush current there. Okay. I know what you mean. I know what you mean. But we are living on the world we are living. What we can do? Nothing. What we can do. Freedom is too expensive. We can't afford it. I can't afford it. Personally, I cannot afford freedom. I wish. Have a nice weekend. Thank you very much. Way too expensive. Guys, have a beautiful Sunday. Not sure what I will do today. I still have a few jobs here. I'll see if I can upload something interesting. Graph menu. Okay, how do I get there? 1 second. Wait, guys. Wait. 1 second. Don't let me like that. 1 second. How do I get a graph? Where is the graph? Wait, I have too much voltage. Okay. Where is the graph? This one? Which graph? It's on the software. I am on the software. This is the software. This one. Where is it? This thingy from here? Let me check. No, it's not a graph. How can I get a graph then? Check on the color box. This one? No, nothing. No. Where, Silvio? Check. Discord. Thank you very much. John, thank you. Thank you as well. Trebuie activated. Opțiunile input. Yeah, but which one? This is data. This one? Okay, and? It's not working. Let's say VBus. Where I have PBus. VBus. This one? It is. It's activated. Check that. It's activated. And I have eBus. This is the current. It's activated. It is, but it's not showing. Play. Laptop fix. Time option. Play. Where is play? This one? Play? Nothing happened. Play. Are not working. Left side, VBus. Left side. No. Okay, guys, I will try to figure it out. I'm going. Yeah, we'll see. Make the app trigger. I can't see it. Make the app bigger. Big enough? I can't make these things bigger. Zoom freely. Play, no, it's not working. Play. I'm clicking play, it's not working. Maybe I will check for a video to see what do I have there. Okay. Good. Yeah. Cool. Guys, see you on the next one. I'm gonna try to upload something. What software is that? Is the meter. I made a video with the meter from Temu. FNIRST. I don't know, it's a weird name. I can't even pronounce it. It was definitely. I know, Sylvie, but no. I'm gonna check. Yeah, how you read that? How you read it? That's the thing. FNIRSI. Yeah. Guys, thank you for being here. Fin error. Fin error. Psi. Fin error psi. Okay. Cool. Cool, guys. Oh, I'm gonna try after that, yeah? Fun. Okay. Okay. Guys, thank you for being here. And see you on the next one, right? Yeah. See you on the next one. Check the links on the description. I'll leave the links for the both videos. Bye. Bye.